So these are of course, the major parts of the X-ray tube. And of course, we shouldn't forget the oil tank. Very, very, very important um, piece of equipment we also have in the X-ray tube. Without the oil tank, the, the amount of heat generated will, will be so much on the anode that it eventually fails. I have told you we have two types of cathode, anode. Um, of course, for the cathode, which is actually the filament, the we have the small focus. And explain that. And the large focus. We use a small focus when we want to image small patient, or when we want to image some part of the body, maybe for without do angiography, we want to use a very, very small focus. That's a small portion of the body. However, I want to image a large portion of maybe chest X-ray, of course, you switch to larger focus. But when children, pediatrics are involved, most times it is usually the small focus that is used. I will get to know all this later as we move into the next one, which is in um, the anode angle. Look at anode, the anode angle, which defines the field coverage. That's one side. In the in the X-ray tube, there is a deliberate introduction of an anode angle for some reasons. We could have an X-ray. We could have an anode this way, so that electrons will just hit it, and then of course be scattered in so many directions. But if you have this, if you do this, the size, we are going to have an issue with the dissipation of heat. We want to have a maximal amount of this anode use, that is a larger surface area of this anode to be used, such that it will aid, it will help in the heat dissipation. So because of that, there is a purposeful introduction of anode angle. So this is the anode angle. Theta. Theta is still the same thing there. For example, you have another one. I want to compare these two anodes. What you're going to have when we have X-rays coming this way, X-rays. When I look at this, this X-ray impinging on this, you can look at the area This is going to cover. Of course, we are just looking at this two-dimensional structure. It's actually, I mean, this is one-dimensional. It's actually two-dimensional. The X-ray comes as a kind of beam this way, beam impinging on them. Assuming this is the surface, it comes this way. So we are actually looking at just one dimension of such a beam, the length. We want to look at this. So this is the area the X-ray is going to hit. If it were to be this, but if we now angulate the anode, this is the effective area it is going to hit. So from mathematics, of course, you see this is can be likened to the hypotenuse of a triangle form. This is just one on the other side of the triangle. So this side is clearly bigger than this side. This side is clearly longer than this side. Consequently, it is going to, this one will have a much more efficient and heat anticipation than this. So this is one of the effects. This is one of the reasons why the anode is angulated to help in the dissipation of heat. This wouldn't be so appropriate. And that again helps us with focal spot size. The focal spot size is actually the area of the anode that the electrons hit. The area of the anode that the electrons hit. We are done with this. We have seen the reason why this is better angulated. So this is the actual focal spot. This is the actual focal spot. Actual focal spot. But this is the effective focal spot. Effective focal spot. So the angle of the angulation of the anode has some things we are going to see on the effective focal spot. How does change of this affect the effective focal spot? It brings us to the principle we call line focus principle. So this is important line focus principle. Line focus principle. Of course, it is a principle that we earlier explained that helps us in dissipation, that helps in effective dissipation of heat. How is this actual focal spot and the effective focal spot related? The more the angle, what effect does it have on the effective focal spot? Of course, the effective, let me use it, effective, is actually actual multiplied by sine theta. So the effective focal spot is actually the actual focal spot multiplied by sine theta. So if you are looking at this focal spot, it is going to be foreshortening. It's going to be foreshortening when one is looking at it from up. If you are looking at it sideways, you see this length. But if you look at it from up, this is what you are going to see. If you look at it from up, as some of us did some little TV school. If you look at it from up, this is what you are going to see. So this is the effective focal spot. And this effective focal spot helps us to shape the useful X-ray beam. How do we mean? And this is the electrons are coming this way. Of course, the electrons coming this way, when they hit this, they are going to be streamlined. Of course, we are looking at this down part because this is where a window is, exit window is. They are not concerned with another X-ray emitted asymptotically in various directions. So this is effective focal spot, which is the useful X-ray that has been produced by this interaction. So this is the one coming out from the window. This is the one that is going to use them on the patient to create the image. So we now have that to we now have this to be this multiplied by sin theta. And the purpose of this angulation is to make sure this is as small as possible. When the effective focal spot is small, it means they're going to have it's going to help us in detail. That is in contrast resolution. I mean, sorry, not contrast resolution. They're going to help us in a spatial resolution. The smaller the effective focal spot, the better the spatial resolution. So we try as much as possible to make this small, but we are not going to make it so small that at the end of the day, we are not going to have anything. For some applications, of course, for general radiography, this mustn't be so small such that you wouldn't have a useful X-ray beam being used on the patient. So the actual focal spot is foreshortened by this line focus principle because of the angulation of the angle. 822. It's not so. I never knew time has been fast spent. I never knew. Okay. I think we can also quickly bring in heel effect here. Heel effect. Another problem, or now a problem. Initially, the angulation here isn't a problem. With the line focus principle, it is actually used to an advantage because it helps in making this as small as possible, helping us with detail, that is with spatial resolution. It also helps in efficient dissipation of heat. But one problem it introduces is the problem, as a heat effect. Because of the angulation of this, some electrons will meet this will travel far inside this place before interacting, whereas others will not travel and so far before interacting. Sorry, some electrons, look at this electron, they will travel this distance before interacting, whereas others will not will interact immediately here. And apart from that, that is for one reason. Some electrons will interact at this end, at this portion. Some electrons will interact deep down here, some very close here, some deep down. So because of this, we are going to have different intensity of X-ray energy because the electrons interactions happen at a different site inside the anode. So the ones that travel far before interacting, we have lesser energy. Whereas the ones that travel minimal distance and inside the anode before interacting, we have maximum energy. So that is the heat effect. The heat effect is as a result of different distance of the travel of the electron inside the anode, giving rise to different varying amount of energy. So the ones closer to the cathode, this is the cathode area. The ones closer to the cathode, we have much more energy than the ones towards the anode side. What do I mean? The X-rays produced closer to the cathode side will be much more energetic than the X-rays produced this area. The X-rays here, will be more energetic than the ones here. Because this one will interact a little bit, whereas the ones deep down here will interact more with so many whatever here before giving of their energy and eventually becoming, being transformed, transformed into X-ray. So this is one of the problems of because of the introduction of because of the ablation of the anode. But then it can be used to an advantage. If you have, if you want to image a patient and you have maybe abdominal side, and the patient has a big tummy or so, it is best to place the tummy, that is the bigger side of the anatomy, towards the side that has more fat. So that, I mean, or towards the one that has more fat, towards the anal side. I mean, towards the cattle side, so that the much more energetic X-rays will be, so this will be, so this is the patient. So you don't have the X-ray tube. X-ray tube is used as cattle. This is X-ray tube. Your position. This is the cathode. This is the anode. So your position it is such that the cathode, the energy, the thicker part of the patient will be towards the anode side. So at the end of the day, we have a better energy spectrum, a better energy distribution as they pass through the anode. I mean, through the patient. The thicker side will encounter much more energetic. So if something goes down, the energy will be reducing, or the reduction in energy has been used to an advantage, so that we now have a kind of better distribution of energy of X-ray. That if these effects were not there, and everything is just the same thing, all the intensity the same thing, you're going to have uneven distribution of energy. That is, let's say 40 keV coming in here, and then 40 keV. You can see, yeah, wouldn't be, this one will encounter lesser tissue, some will encounter more tissue. At the end of the day, our receptor, we now have various energy. And at the end of the day, we have 15 here, 15 here, here we have 20, here we have 30, and have, you can see the different energy at the end of the day being I mean photons on our image receptor. I think this is around 828. We want to stop here. Except we still want me to continue. We want us to stop here. We would like to.
Good morning, sir. We can stop here for today, sir.
Okay.
Continue on Wednesday.
Okay.
Yes, sir.
If you have any questions, you can do well to ask them before we call it a day. Do you have any questions? Okay. Dr. Bola, do you have anything?
No question for me, sir. No question for me, sir.
Okay. I thought you wanted to ask question. Okay.
Thank you very much.
I want to wish you a great week ahead. Bye-bye.
Thank you. You too, sir.
Thank you very much once again for the amazing teaching, sir. God bless you.